categories of embedded system based on the functioning and performance. Those are standalone embedded system, real-time embedded system, network information appliances, and mobile devices. Standalone embedded system works in standalone mode. They take inputs, process them, and produce the desired output. The input can be electrical signal from transducers or commands from human being. The output can be electrical signal to drive the another system on LED or display, LED display or LCD display for displaying the information to the users. For example, process control, automobiles, consumer electronics, etc. Then second type is the real-time systems. These systems has some specific work has to be done in specific time period. They are called real-time system. They are again classified into two types, hard real-time systems and soft real-time systems. For hard real-time systems, they have to follow the deadline strictly, while soft real-time system in which few delays or some delay doesn't cause serious implication. Next is network information appliances. Embedded system provided with network interfaces and access by network such as LAN or internet are called network information appliances connected to network through TCP/IP protocol suite. So let us consider this example of weather monitoring system. It is an example of network information appliances. The, with the help of network, weather monitoring will be carried out. Next is the mobile devices. Mobile devices such as mobile phones, personal digital assistants, smartphones, etc. are special category of embedded system. Next is the overview of next point we are going to see is the overview of embedded system architecture. Embedded system architecture can be considered as layered architecture. It has different layers such as hardware, operating system, and application software. Embedded system consists of hardware built around the CPU. This hardware also contains the memory. Software is loaded. The software residing on the memory chip is called as firmware. So let us see this layered architecture. It is not compulsory to have operating system in each and embedded system. If the application is simple, then operating system may not be required in those embedded systems such as toys, ACs, remote control units. In these embedded systems, operating system will not be required. Embedded architecture can be represented as a layered architecture as shown in figure. The OS runs above hardware and application software runs above operating system. For complex processing, it is necessary to have an operating system. In this case, it is necessary to integrate the application software with operating system, then transfer entire software onto the memory chip. Once the software is transformed to memory chip, it will continue to run for a long time and it doesn't require to reload once again the new software. Next, we'll see the components or building blocks of the embedded system. So these are the hardware. This is the hardware architecture of an embedded system. The major component is the main component of embedded system is CPU. Then these are the memory, the input devices and output devices, communication interface, and application specific circuitry. So let us see the components one by one. First is the CPU, which is the core of embedded system. It can be microcontroller, microprocessor, or DSP. Based on the desired application, we can choose the CPU, which is being suited for particular application. For small applications, microcontroller or microprocessor may be used. While the application is involving signal processing, then DSP will be used. Memory, there are two types of memory, RAM and ROM. RAM will be erased on the power switch off. RAM will not be erased after power switch off. So firmware is always stored into the ROM. So when power is turned on, processor reads from the program and then it is transferred to RAM and executed. Then next is the input devices. Actually, embedded system has very limited capability to interface the input devices. It is very difficult task. Only few embedded system may come up with small keypad. Many embedded system does not have input device for the user interaction. They take inputs directly from the sensors, transducers, and produce the electrical signal that are fed to the other system. Output devices, embedded system also have limited capability for the output devices. For example, some embedded systems come up with LEDs, LCDs, or alarm interfaces. Then next is the communication interface. Embedded system may need to interact with other embedded system and may have to transmit the data to computer. To facilitate this, embedded systems are provided with communication interfaces such as RS-232, RS-422, RS-455, Universal Serial Bus, IEEE 1294, Ethernet, etc. Application-specific circuitry, sensors, transducers, special processing and control circuitry may be required for an embedded system depending on the application. This circuitry interacts with processor to carry out necessary work. Power supply may be provided with 230 volt or through battery. Reliability, embedded system needs to be highly reliable. It should work for thousands of hours without break. Many embedded systems used in industrial control are inaccessible. They are hidden in some other large size equipment. Hence, they will not be reset button on such systems. For example, automatic reset may be required. Special hardware needs to be built into the system to take care of it. The special module is known as watchdog timer. Many embedded systems used in industrial automation and defense equipment need to work in extreme environment conditions such as high temperature, low temperature, high humidity. Besides this, they should be able to withstand bump and vibrations. The ability to work reliably in extreme environment conditions known as rigidness. Not only military equipment, even consumer appliances such as mobile phones need to be very rugged. Many people keep dropping their mobile phones on floor, but still it has to work because of it is rugged device. So in the next lecture we'll see quality attributes